In prior years, Pierre, the quality assurance manager at GMPC Corporation, a global manufacturer of personal computers, spent much of his time reacting to product quality issues. A lack of accurate data and detailed data about product quality and manufacturing data made it difficult to process information requests from the business. Complicating life further was a poor infrastructure for collaborating with other plants on such matters. GMPC is now using FlexNet from Apriso, a solution to better manage manufacturing operations within a plant while also synchronizing operations globally. FlexNet was built on a platform that is based on several Microsoft technologies, including Microsoft Office, Microsoft SharePoint, and Microsoft SQL Server. The new solution allows QA personnel like Pierre to become less reactive and lets GMPC contain product quality issues quickly before they reach the customer. In this scenario, GMPC has just started production on a new line of mini PCs. Shipments of motherboards from Pierre's component plant in Paris to a final assembly plant in Poland have already started. Pierre has just received a call from an inspector on the shop floor who has provided him with a batch of failed motherboards related to the product. In the containment management screen of FlexNet, Pierre creates a new electronic record to manage the quality issue known in FlexNet vocabulary as a containment. Pierre identifies and tracks the motherboards affected. The system has global reach. It's used by GMPC to prevent quality issues from making their ways to other manufacturing sites or from being shipped to the customers. In the Paris plant FlexNet containment screen, Pierre adds the serial numbers to the containment. He knows that the failures are all associated with the new 330 mini PC product. He uses the application's search capabilities to identify and add the serial number range into the containment. In the past, Pierre would have been scheduling teleconferences and sending a host of emails to the quality staff at the affected plants to prevent disaster. This was a time-consuming process, prone to error. The FlexNet solution is not just plant-centric. By utilizing Apriso's global manufacturing portal, quality issues can be addressed quickly across all locations. Affected plants are notified through a series of workflows that are automatically launched by the system to help GMPC manage global containment activities efficiently on a global scale. Spanning the FlexNet servers used to control manufacturing operations at the Paris and other plants worldwide, as well as at the corporate office, the system utilizes the Microsoft Windows Workflow Framework to manage the activities associated with a global containment. These technologies allow the IT organization at GMPC to configure each of the specific details governing exactly how they wish to manage the life cycle of product quality issues. Since it is late on a Friday afternoon, Pierre switches over to the Apriso Global Manufacturing Portal to ensure the Krakow plant is taking preventative measures. To do this, he opens up the containment screen and filters on the containments issued in Paris. He quickly locates the containment involving the mini PC boards and explores the details. The system indicates that it has notified someone in Krakow named Pavel, the QA manager on duty. His active status is signified by the green presence indicator to the left of his name. Pierre decides to initiate a two-way voice collaboration with Pavel by clicking the appropriate option. Detecting the presence of and initiating collaborative sessions through voice, video, or instant messaging is made possible through the Apriso portal with Microsoft Link 2010, a key pillar of Microsoft's unified communications capabilities. The email Pavel receives is generated by the system, which knows, based on system-configured roles, that Pavel is a first-line response person in the Krakow QA department. The notification Pavel receives tells him to review and activate the containment in his plant. An alternative policy may have been to place the items on hold automatically, depending on rules such as how many items are involved, their cost, and other factors. From within the containment management screen of the FlexNet portal controlling the Krakow plant, Pavel checks if there were any consumed by production. By filtering on only those boards involved, he checks the parent serial column and is relieved to discover that none made it into the final product. Pavel concludes his review of the containment by clicking on the link in his email. The motherboards in both Krakow and the sending plant in Paris are now safely on hold. In the ensuing days, a root cause analysis of the issue identified a GPS chip incompatibility with the motherboard design. all the boards produced were placed into containment. To correct the problem, engineering was involved to change the motherboard design, planning updated ERP, and purchasing ordered new GPS chips from the supplier. Upon being notified that the new GPS chips were received, Pierre launches rework orders in Paris to repair the motherboards on containment. First, Pierre verifies that the engineering change is reflected in the system. He does this by selecting BOM maintenance from within the FlexNet portal. He filters on the mini PC motherboard part number and quickly navigates to view its component listing. By selecting the GPS chipset item shown at the top, he notices it expired in early June. He proceeds to select the replacement item just below and confirms it is valid from June onward. Feeling comfortable both engineering and planning have done their jobs well, Pierre creates a work order to repair the motherboards in containment. From the process dropdown, he selects the board repair process that engineering has specifically authored to fix the motherboards. Pierre reviews and sets a few other parameters and enters the serial number range of the first batch of motherboards to be repaired. Upon order creation, the system generates and dispatches tasks to the appropriate work centers in the sequence required to repair each board and to perform a retest. From the FlexNet portal, an assembly worker named Francois, who is working in the repair work center, sees the new tasks in his console and selects the first one. Francois is presented with two main steps, one instructing him to perform the rework itself, and the second to update the motherboard's genealogy. He selects the first and is presented with detailed step-by-step work instructions covering exactly what to do, and showing an image of where on the motherboard the GPS chip is to be found. Upon finishing the actual rework minutes later, he proceeds to the next step, where he updates genealogy. Here, Francois highlights the GPS chipset component he has removed, and enters details for the new GPS chip he has just added. He selects Replace, thereby confirming the repair operation for the first motherboard. At this point, they are placed on a rack awaiting a successful retest at the next operation before being released from containment. With the new approach and system, the QA staff spends considerably less time being reactive and can now focus more energies on an investigation into the root causes of the issue and the extent of what boards are involved to then take appropriate preventative actions. The benefit of a global quality system is that users can collaboratively address issues quickly, and it helps manufacturers to achieve and sustain the highest levels of manufacturing excellence. By synchronizing plant-level operations with planning and engineering design, it is possible to achieve engineering nirvana of planning anywhere, designing anywhere, and building anywhere. And that is good news for not only both Pavel and Pierre, but for you and your customers as well.